Alright, boys and girls, welcome to our first video lesson in Chapter 5. It's a double lesson on sections 5.1 and 5.2 on triangle parts. Alrighty, here we go. Parts are parts. Okay, the first word we need to know is perpendicular bisector, and it's actually going to be the first part of our triangle that we're going to talk about right now. Okay, I have right here in this red line right here. This red line is a perpendicular bisector of the black line, because the black line right here, see that black line right there? That black line is bisected. It's cut in half into two equal pieces, as we can see right here, cut into two equal pieces by the red line. And the red line is also perpendicular to the black line. We see the right angle right here. So therefore, that red line is the perpendicular bisector of that line. Okay. We also have a word equidistant. Equidistant is exactly what it sounds like. Equidistant means the same distance away. And we will use that word, the same distance, from 2 points. And we will use that word in a theorem tomorrow called the perpendicular bisector theorem, but we will use that in class. One more word you need to know, concurrent. Concurrent lines are three or more lines that intersect at one point. And where they intersect, that one point where the three or more lines intersect, is called the point of concurrency. So if three or more lines intersect at one point, they are concurrent. And that point where they meet, that point is called the point of concurrency. So every triangle has three perpendicular bisectors. So I'm going to draw in right here. Here's the midpoint of the first line on the right side. And if I draw a line that's perpendicular to that, it's going to look like that. That's a perpendicular bisector. If I find the midpoint of the bottom line right here, I draw a perpendicular bisector of that line. It's going to look like this. And if I find the midpoint of my third line and draw a line that's perpendicular to that, and I'll do that in black. There's my midpoint, and I'm going to draw a line that's perpendicular to that. There it is, right there. Okay, this point right here now, this point right here is the point of concurrency of those three lines, and a triangle has three perpendicular bisectors which are concurrent. And that point of concurrency is called the circumcenter. Circumcenter. And you'll see why right now. So every triangle, no matter what type of triangle it is, whether that triangle is an acute triangle, whether it is an obtuse triangle, or whether it is a right triangle, every single triangle has a point of concurrency where the three perpendicular bisectors meet, and that point is called the circumcenter. And the reason it is called the circumcenter is because that point, the circumcenter, is the center of a circle that can be circumscribed around each of these triangles, where it touches each of the vertices of the triangle. And we will look at as to why that is true in class mañana. Okay? The second special part of a triangle is called the angle bisector. Of course, an angle bisector cuts an angle in half. Okay? We will talk about the angle bisector theorem tomorrow. Okay? But the angle bisector, each triangle has three angle bisectors. The first one from the top angle. Hey, I'll switch colors here just for the fun of it. The first angle bisector, if I draw this line, splitting that angle in half, I'm doing this the best I can here. There's my first angle bisector in green. My second one I'm going to draw in blue from the bottom left-hand vertex here. So the angle bisector cut that angle in half. So this angle is congruent to this angle. And I probably should have marked this here. This angle is going to be congruent to that angle. And if I draw the third angle bisector, and I'm going to do that in a different color. How do I choose my colors? Well, I'll do it in black, I guess. Here's the third angle bisector. I'm chopping that angle in half. There's my angle bisector. Again, this angle is congruent to this angle. Okay? Notice that they again meet at a point. And that point is called the incenter. So every triangle has three angle bisectors. Those angle bisectors are concurrent. Their point of concurrency right here, the point of concurrency is called the incenter. The incenter of that triangle. Okay, there's the incenter theorem. We'll talk about that mañana. But again, every incenter is now the center of the inscribed circle, the circle that can be drawn inside the triangle, touching each of the three sides of the triangle. So the point of concurrency for your angle bisectors is called the incenter. So we have two special parts so far. We have the perpendicular bisector, their point of intersection is called the circumcenter, and we have the angle bisector, their point of concurrency is called the incenter. Let's move on to 5-2. 5-2 has two more parts. The first one is the median, which you already know. You've seen this word a bunch of times. It is a segment that's drawn from the vertex of one triangle to the midpoint of the opposite side. So as I look from vertex C, this red line is the median of that triangle. It's drawn to the midpoint of AE at point F, the midpoint. The blue line here, drawn from vertex E, is drawn to the midpoint of the opposite side, so B is the midpoint of AC. And here in vertex A, the green line here is the median of from that vertex drawn to CE at its midpoint D. Notice now that once again, those three lines, those three medians, are concurrent lines, and the point that they meet at is called the centroid. And actually, I have it written right here, the centroid. Okay? And now, the last special lines inside all triangle is called the altitudes. Altitudes are drawn from the vertex of a triangle perpendicular to the opposite side. So let's draw in this first triangle here, the acute triangle. There's one altitude. The second altitude is from A. Looks like that. And the third altitude, whoop, looks like that. Those are drawn from the vertex to the opposite side, perp. Notice the right angles right there, vertex to the opposite side, perp. Notice the right angles, vertex to the opposite side, perp. That point of concurrency is called the orthocenter. Same thing is true in a right triangle, but this is a little bit trickier now because the altitude for two of the vertices is actually the line of the triangle. So from point L, there's one of my altitudes. From point J, here is my other altitude. And now, let me get a different color. How do I do that? There we go. Let's get back to red. Okay, my third line right here. That's not my altitude, I'm sorry. My third altitude is right here. That's the right angle. Notice the point of concurrency is right here. There's my orthocenter. And in an obtuse triangle, so in my third triangle here, the obtuse triangle, I'm once again going to have three altitudes. And these can be a little bit harder in the obtuse triangle because first thing you need to do is you need to extend two of your sides. So I'm going to extend side VW here in orange. So it looks like that. I'm going to extend WX. So it looks like this. Okay, let me switch colors here. I'll go in green. My first altitude is pretty easy to draw from W. That goes down right here. And what I'm going to do is I'm just going to extend that altitude both ways. My second altitude is drawn from V. I'll do that in blue. So I need to draw this from V perpendicular to the opposite side. So you got to do it to the extension. So it's perp, and then I'm just going to extend that through so it looks like that. There's my right angle. Here's my right angle down here. And the third altitude drawn from X, let's do that in red. So I start at X, and I go down. Sorry, start at X, go down. There's my right angle right there, and I'm going to extend that altitude. And we see now once again that all three altitudes are concurrent, and their point of concurrency is called the orthocenter. And the orthocenter is not really special, but again, it's kind of neat that they all meet at one point. So there again, we can see all those altitudes drawn in those three triangles in red, blue, and green. Okay, notice the extension. Notice the extension right here in the obtuse triangle. That's extended, and that is extended as well right here. My orthocenters are, here in the first one, it's inside in the first triangle, in the acute triangle. In the right triangle, my orthocenter is actually the vertex of the right angle, and my orthocenter in the obtuse triangle is actually outside of the triangle. All right, folks, we'll look at this triangle tomorrow. Have a great day, and hasta mañana.